Imagine everything you've ever learned about the universe. Every textbook, every lecture, every documentary being turned upside down in a single moment. We've been taught that stars collapse into fiery chaos, that the cores of neutron stars are the densest, most violent places in the cosmos, where matter is crushed into a seething soup of neutrons. But what if that's all wrong? What if instead of chaos, a collapsed star could punch a hole through reality itself, creating something that looks like a portal to another dimension? NASA's Quantum Structures Lab has been probing a neutron star labeled XJ3729 with cutting-edge quantum resonance mapping, and what they've uncovered at its core isn't plasma, isn't degenerate neutrons, it's a perfect vacuum. No particles, no radiation, nothing. Spectral readings reveal an energy-locked void, a region of zero entropy that defies every law of thermodynamics we've ever known. Scientists are calling it the void core, and it's sending shockwaves through the astrophysics community. Is this a bizarre natural anomaly, or something far stranger? In the next few minutes, we're diving into a discovery that could rewrite physics, unravel the fabric of space-time, and make you question everything you thought you knew about the cosmos. Buckle up. This is going to be a wild ride. Let's start with the raw data. The Quantum Structures Lab, a pioneering facility blending quantum optics and astrophysics, spent months scanning XJ3729, a neutron star 1.9 times the mass of our Sun, sitting just below the threshold where it should collapse into a black hole. They used quantum resonance mapping, a technique so advanced it sounds like science fiction. By firing entangled photon pairs through the star's gravitational field and measuring tiny phase shifts, they built a 3D map of its core with sub-centimeter precision. Over 3 months, they collected 10 billion measurements processed by supercomputers running at petaflop speeds. What they found stopped them cold. A cylindrical tunnel, 10 kilometers long and 5 kilometers wide, where space-time folds inward on itself. This isn't just empty space. It's a void with zero entropy, meaning no heat, no motion, no randomness. Thermodynamics says entropy must increase in any closed system, yet here's a natural object where it drops to absolute zero. This is like finding a room in your house where time doesn't exist. The team had to recalibrate every instrument, rewrite their analysis software, and double-check their math. But the data held firm. This void is real, and it's unlike anything we've ever seen. Now let's back up and talk about how this star first caught their attention. XJ3729 wasn't just another blip on NASA's deep space arrays. Its radio pulses, those rhythmic beats neutron stars emit as they spin, were arriving in a pattern that raised eyebrows. Sequences of 2, 3, 5, 7, 11, 13, 17 prime numbers. For weeks, the pattern held steady, ruling out noise or equipment glitches. What kind of cosmic engine encodes prime numbers into its heartbeat? To dig deeper, the team synchronized their quantum mapping to these pulses, using a global network of radio telescopes and a lunar laser relay originally built for Earth-Moon ranging. The result was a dynamic map showing the void shifting slightly as the star spun, anchored to its magnetic axis. This wasn't just a static anomaly, it was alive, pulsing in rhythm with the star itself. The implications hit like a thunderbolt. This void might not just be a quirk of physics, it could be a gateway, a tunnel through space-time that mimics theoretical wormholes. Let's pause for a second to grasp what this means. Neutron stars are born from the ashes of massive stars, 8 times the Sun's mass or more, that end their lives in supernova explosions. When the core runs out of fuel, gravity crushes protons and electrons into neutrons, forming an object so dense a teaspoon of it weighs 1 billion tons. We've modeled these stars for decades, using equations from general relativity and quantum mechanics. They should have chaotic cores, superfluid neutrons, maybe quark-gluon plasma, magnetic fields trillions of times stronger than Earth's. But XJ3729 laughs in the face of those models. Its core isn't chaotic, it's silent, ordered, empty. The void's geometry, when visualized, forms a symmetrical tunnel, held open by forces we can't yet identify. It's as if the star didn't just collapse, but carved out a piece of reality, leaving a hole where physics as we know it doesn't apply. So what could this void be? The first theory is jaw-dropping. It might be a wormhole, an Einstein-Rosen bridge straight out of general relativity. Wormholes are theoretical tunnels connecting distant points in space-time, but they require exotic matter with negative energy to stay open. Quantum field theory allows for tiny amounts of negative energy via the Casimir effect, but stabilizing a wormhole inside a neutron star would need far more. Could the extreme gravity near the core amplify quantum effects to produce this exotic matter? The data leans in this direction. Pulses entering the void re-emerge on the star's opposite side, with time delays matching a throat radius of about 5 kilometers. These delays are consistent across multiple observations, suggesting a stable passage through space-time. If this is a wormhole, it's not just a cosmic curiosity, it's a portal to somewhere else. Maybe another part of our universe, or a different one entirely. But there's another possibility, equally mind-bending. What if the void is a false vacuum bubble? In quantum field theory, a false vacuum is a metastable state with higher energy than the true vacuum. Under extreme conditions, bubbles of true vacuum can form, potentially expanding and rewriting the laws of physics. Inside XJ3729, a bubble of lower energy vacuum could counter the star's crushing gravity, creating a pocket of alternate physics. The bubble's wall tension and energy difference would push outward, balancing the collapse. This raises a chilling question. If this bubble grows, could it trigger vacuum decay, converting our universe into a different state? Are we staring at a cosmic bomb or a contained anomaly? Both the wormhole and false vacuum theories stretch our understanding to the breaking point, but they're just the beginning. Here's where things get even weirder. While monitoring XJ3729 with NASA's Deep Space Network, engineers picked up a faint signal not from the star's coordinates, but from a slightly offset vector. At first they thought it was interference, but cross-referencing with very long baseline interferometry confirmed it came from the same patch of sky. The signal's timing matched the star's prime number pulses, but its pattern followed the golden ratio: 1.618, 2.618, 4.236, and so on. This sequence, found in nautilus shells, sunflower seeds, and even human brain waves, is nature's signature of harmony. Could the void be encoding information in a way that mimics life itself? Some theorists suggest it's an interference node between higher dimensional membranes, or brains, in string theory. Our universe might be a three-dimensional brain in a higher dimensional bulk, and where brains collide, energy could tunnel between them, creating resonance patterns like the golden ratio. Others propose the void is a quantum channel, with entangled particles carrying information back and forth, self-optimizing its structure like a cosmic neural network. This isn't just physics, it's the universe whispering secrets that sound eerily alive. Take a moment to let that sink in. What if the cosmos isn't a cold, indifferent void, but a vast, interconnected web? Ancient philosophers saw the universe as a living organism, a great tree of life. Now science might be catching up. A portal-like void pulsing with prime numbers and golden ratios blurs the line between inanimate matter and something more. Are we just observers, or are we part of a galactic network, nodes in a cosmic mind? This discovery forces us to rethink our place in the grand scheme, and we're not done yet. Now let's push the boundaries further. Some quantum theorists argue the void is a brain collision point, where our universe touches another in a higher dimensional bulk. In string theory, brains can collide, exchanging energy or particles. If XJ3729 is a brain anchor, it could be a stable channel to another realm with different physical laws. But there's a bolder idea. What if this is artificial? A Type 2 or 3 civilization, capable of harnessing entire stars or galaxies, could have seeded neutron stars with quantum locks to regulate vacuum energy, ensure cosmic symmetry, or even communicate across vast distances. Supporting this, neutrino detectors found zero flux from the void, and X-ray observatories saw no thermal emissions. Nothing natural explains a structure this stable. The Quantum Structures Lab calls this quantum anchoring, a phenomenon where certain objects lock onto different vacuum states and hold them in balance. On Earth, we've seen this in tiny superconducting circuits, but on a cosmic scale, it screams engineering beyond our wildest dreams. The debate is fierce. Some argue natural brain collisions are more likely, citing M-theory models that predict such nodes in high-mass regions. Others insist only artificial design could achieve this precision. Both sides agree. XJ3729 is a game-changer. But just when it seemed we'd hit peak astonishment, the team found something that turned the mystery up to 11. A second neutron star, XJ3742, 11 light-years away, showed the same void core anomaly. Initially overlooked, it was scanned on a whim, revealing an identical tunnel, the same prime number pulses, and zero entropy. The real kicker? When observations of both stars were synchronized using atomic clocks and interplanetary laser links, their pulses matched to within microseconds, despite being 10 light-years apart. This defies causality unless they're connected outside normal space-time. To make sense of this, the team ran a 4D simulation, linking the two voids. The result was a geometric lattice, a network of nodes and edges spanning the distance between the stars. This lattice aligns with unexplained gravitational anomalies in the Gaia star catalog and LIGO's gravitational wave data, hinting at a hidden cosmic architecture. One physicist called it a nervous system for the cosmos, a grid that might regulate star formation, galactic rotation, or even dark matter. What was once an isolated oddity now looks like part of a galactic superhighway, a network of portal-like nodes coordinating processes across unimaginable distances. The universe isn't just a random scatter of stars. It might be a living, interconnected system, and we've just found its first threads. This discovery shatters everything we thought we knew. Whether these voids are natural brain anchors, false vacuum bubbles, or cosmic engineering, they reveal a universe far more ordered and dynamic than we ever imagined. This isn't a sci-fi portal you fly a spaceship through. It's a gateway of information, a hidden network woven into space-time itself. Over the next few years, the Quantum Structures Lab and other teams will target more neutron stars, refine their quantum mapping, and deploy new interferometers to map this lattice across the galaxy. We might find these nodes control everything from star birth to dark matter's behavior. The implications spill beyond astrophysics. Understanding how information flows through space-time could revolutionize quantum communication, computation, or even our view of consciousness. Of course, extraordinary claims need extraordinary evidence. New observatories like the upcoming Quantum Gravity Telescope and upgrades to LIGO and Virgo will test these findings. If confirmed, this network could be the biggest discovery in centuries, rewriting physics and redefining our place in the cosmos. We've cracked open the first node, but the real journey, mapping this cosmic web, is just beginning. Picture a universe where every neutron star is a synapse, every void a signal, and every pulse a thought. What does that make us? Are we just specks in a vast machine? Or are we part of something greater, something alive? This is where the story pauses, but not for long. The void core of XJ3729 and its twin XJ3742 are just the start. Soon, we'll dive into another mind-bending puzzle. What happened when quantum entanglement was tested across interstellar space, and the particles didn't just respond, they predicted. Entangled photons beamed between Earth and the Voyager probes may have hinted at future events, and we'll explore whether this ties to the void core network. Could we harness these connections to send information faster than light, or challenge the very limits of causality? The universe is talking, and we're just starting to listen. Stay tuned. You won't want to miss what's next. The universe has always been a place of mystery, but what if its deepest secrets aren't hidden in distant galaxies or ancient light, but inside the hearts of collapsed stars? NASA's Quantum Structures Lab has uncovered something in neutron star XJ3729 that doesn't just challenge our understanding, it obliterates it. Forget everything you thought you knew about stellar cores, because this isn't a crushing inferno of neutrons or a chaotic soup of exotic particles. It's a void so perfect, so empty, it defies the laws of physics. A region of absolute nothingness, a portal-like anomaly that pulses with patterns that scream intelligence, or something even stranger. This discovery isn't just a footnote in a science journal. It's a cosmic bombshell that could mean the universe is hiding gateways to realms we can't even imagine. Let's dive into the latest, most shocking findings, peel back the layers of this enigma, and explore why this void might be the key to unlocking the ultimate truths of existence. The Quantum Structures Lab, a hub of cutting-edge science where quantum mechanics meets cosmic exploration, has been relentless in probing XJ3729. Their latest scans, conducted in early 2025, used an upgraded quantum resonance mapping system, now enhanced with photon entanglement arrays that operate at unprecedented precision. These arrays fire synchronized photon streams through the star's gravitational field, capturing phase shifts so minute they reveal space-time distortions smaller than a proton. The data, processed by AI-driven supercomputers with neural networks trained on cosmic simulations, paints a picture that's equal parts mesmerizing and terrifying. At the star's core lies a cylindrical void, 12 kilometers long and 6 kilometers wide, where space-time doesn't just bend, it collapses inward, forming a tunnel that seems to lead nowhere and everywhere. This isn't a black hole's event horizon or a neutron star's dense core. It's a region with zero particles, zero radiation, and, most shockingly, zero entropy. In a universe where chaos is king, this void is a silent, ordered rebellion against reality itself. What makes this discovery even more electrifying is the star's behavior. XJ3729 doesn't just sit there, it sings. Its radio pulses, detected by a global array of telescopes linked through quantum-encrypted networks, follow a sequence that's mathematically pristine. Prime numbers, but now with a twist. Recent observations show these pulses modulating in a fractal pattern, repeating at scales that mirror the Mandelbrot set, a mathematical structure known for its infinite complexity. This isn't random noise. It's a signal so intricate, it feels like the star is trying to communicate. The team cross-referenced this with data from the Square Kilometre Array, the world's largest radio telescope, and found the fractal pulses align with cosmic microwave background fluctuations from the early universe. Could this star be echoing the birth of the cosmos itself, or is it broadcasting something even more profound? The void at its core seems to be the source, a cosmic amplifier, turning raw energy into patterns that resonate with the universe's deepest rhythms. But the real gut punch came when the team pushed their quantum mapping further. By integrating data from neutrino observatories and gravitational wave detectors, they found something that sent chills through the scientific community. The void isn't just a static anomaly, it's dynamic, oscillating in sync with the star's magnetic field. Every 17 milliseconds as the star spins, the void's geometry shifts, creating ripples in space-time that propagate outward. These ripples, detected by LIGO's latest ultra-sensitive interferometers, carry a signature that defies explanation. They encode the Fibonacci sequence, each wave's amplitude scaling by the golden ratio. This isn't just physics, it's art, a cosmic symphony played on the strings of reality. The team theorized that the void might be a resonance chamber, amplifying quantum fluctuations into macroscopic patterns. But why? Is it a natural phenomenon? Or is something or someone tuning this star like an instrument? Let's explore the leading theories, each more mind-blowing than the last. One hypothesis suggests the void is a stabilized wormhole, but not the kind you'd see in a sci-fi blockbuster. This is a quantum-scale tunnel, potentially connecting our universe to a parallel one with different physical constants. Recent simulations, run on quantum computers with 512 qubits, show that the extreme gravity inside a neutron star could create conditions where space-time tears, just enough to form a microscopic throat, held open by quantum vacuum energy. The catch: the void's stability requires a feedback mechanism, a kind of cosmic thermostat that balances the tunnel's collapse. Data from XJ3729 shows energy fluctuations at the void's edges that match predictions for this feedback, hinting that the star might be a natural bridge to another reality. Imagine it. A portal not for ships or people, but for information, energy, or even consciousness, linking our cosmos to places we can't yet fathom. Another theory takes a darker turn. The void could be a quantum scar, a remnant of a phase transition in the early universe. Cosmologists have long speculated that as the universe cooled after the Big Bang, it underwent shifts in its vacuum state, like water freezing into ice. These transitions could leave behind defects, cosmic strings, domain walls, or, in this case, pockets of wrong vacuum. The void in XJ3729 might be one such pocket, a bubble where the laws of physics are slightly off, preserved by the star's immense gravity. Recent particle accelerator experiments at CERN, probing vacuum stability, suggest such pockets could exist, but finding one in a neutron star is like stumbling on a fossil of the universe's infancy. The danger? If this bubble destabilizes, it could expand, rewriting physics across light years. We're not just looking at a portal. We might be staring at a cosmic trigger. Then there's the wild card, the void as a cosmic artifact. In 2025, the search for extraterrestrial intelligence received a funding boost, driven by renewed interest in techno-signatures, signs of advanced civilizations. Some researchers now argue XJ3729's void could be a quantum anchor, a device engineered to stabilize space-time or channel energy across galaxies. The star's fractal pulses and Fibonacci ripples resemble error-correcting codes used in quantum computing, suggesting the void might be processing information. Supporting this, the void emits no detectable neutrinos or X-rays, an anomaly no natural process explains. Could a civilization millions of years ahead of us have turned this star into a beacon, a node in a galactic internet? The idea sounds outlandish, but the precision of the void structure, its perfect geometry, its defiance of entropy, feels like the work of a mind, not chance. The plot thickened when the team discovered a third neutron star, XJ3751, 8 light-years from XJ3729, with an identical void core. This wasn't a fluke. Using synchronized observations via laser-linked satellites, they found all three stars' pulses align in a triangular lattice, their voids resonating like tuning forks. The lattice's geometry matches anomalies in the Gaia star catalogue, where unexplained gravitational tugs hint at invisible structures. Gravitational wave data from Virgo's 2025 upgrade further supports this, showing faint echoes of a network linking these stars. It's as if the galaxy has a skeleton, a hidden framework of void cores that might regulate its dynamics. One astrophysicist described it as a cosmic circuit board, with each void a processor in a system spanning light years. If this network exists, it could explain mysteries like the galaxy's unexpectedly stable rotation curves or the clumping of dark matter. But the most haunting discovery came from a new experiment. In March 2025, the team used XJ3729 as a gravitational lens to study distant quasars, bending their light to probe the void's effects. The results were staggering. Light passing near the void showed time dilation patterns that didn't match general relativity. Photons seemed to skip time, arriving fractions of a second earlier than predicted, as if they'd taken a shortcut through the void. This suggests the void isn't just a hole in space, it's a hole in time, potentially connecting past, present, or future. Quantum simulations propose the void could be a temporal junction where space-time loops back on itself. If true, this isn't just a portal to another place, it's a gateway to another when. The implications are dizzying. Could we send signals through this void to glimpse the universe's past or future? This discovery isn't just about physics, it's emotional. It makes you feel small, yet